Alright, I'm going to do a little video about the air compressor in my garage that might help you. This is a Harbor Freight air compressor. I'm going to let some air out. Oh, let me turn it on. It's not on. You'll see about all this stuff in just a minute. It's on now. Alright, let some air out. Let the tank pressure go down. There's a lot of air in that tank. Alright. So you see that it automatically kicked on when the air got down to what, 100, 100 and I don't know, 20. All right, so here is how this all works together. This is a Husky 175 psi. Shit, I don't know, 30-gallon tank. There's the original compressor that came off of it. Piece of shit. You know, 1-cylinder electric. Well, electric's not bad. Okay. Here is the drawing, the wiring diagram. All right. So, you see on this diagram, there's a switch outlet combination, which is kind of the center of everything. There's a relay, also known as a contactor in the HVAC industry. This is the pressure switch. Right here is the pressure switch that my dad installed. All right, and the wiring comes off the pressure switch. Let's fix that. The wiring comes off the pressure switch, black wire, and plugs into that. More about that later. So my dad had this set up in his shop, and he had all the wires hanging out everywhere. The relay just screwed into the wall. And I wanted a cleaner look. I wanted everything inside the wall. So I modified my dad's drawing to be this drawing. I drew this. So this is from the house. This is 120 volts from the house. I went up in the attic and I branched off of the garage light circuit. So I got 120 coming into the wall. I went up in the attic. There was a, your mileage will vary, of course. There was a 220 volt line running up to the heater that was not being used. There was two running up there. One was being used, the other was not being used. So I brought that down and put it down into the wall here. So behind this wall there is 220 and 120, or 240 and 120. So I thought, you know what, while I'm at it, I'll go ahead and put in some outlets. So these four outlets are regular 120 volts, 20 amps. This switch is not connected, it does not provide alternating current via the plug. The switch is simply a means to connect the pressure switch on the generator, on the tank, the pressure switch on the tank to the relay. So what happens is the line comes in, that's the hot 120 volt comes in, goes to the switch. Okay, flip the switch and it comes out of the switch comes out of the switch right here, the yellow. Comes out of the switch, goes down to the outlet, which we're not going to call an outlet anymore. We're going to call it a connector, because it's not an electrical outlet. So it goes, the hot gets switched and comes down to the connector. Goes out the connector, right here, goes out the connector to the pressure switch, and then from the pressure switch back to the other side of the connector. Comes off of that, goes to the relay. Now, so here's coming from the pressure switch, right? It's coming from this side of the connector to the pole on the coil. 120 volt coil. Don't make my mistake and buy a 220 coil because you think you need 220 power. This is a standard HVAC relay or connector. It gets 120 this side and this side here. We'll see about that in a minute. So it goes out, comes back, comes to the coil. Other side of the coil is that yellow one. Other side of the coil goes to the white on the house, thus completing the circuit. Now, when this switch is on, the coil is energized if the pressure switch says, hey, we don't have enough pressure. So when the pressure switch says, hey, we don't have enough pressure, it completes the circuit here and ties this all together. Right now, if there is enough pressure, it's not completed. It's open. But when there's not enough pressure, that closes that circuit, and then the power goes through that coil, and causes the relay to turn on or connect, which causes the 220 that's coming from the house to be connected to the outlet right here. All right. I don't know if that's, I hope I explained that right. But you can take a screenshot of this, or you can PM me and I'll send you the actual file. This is from Harbor Freight. This, I don't know where my dad got this. He built this stand for it. Put the pulley on it. So the air from the compressor comes out of the compressor right here, goes up this big fat line. It's the fat line right here, this fat line. Boom. The air coming from the compressor goes into this radiator, which cools the air. It comes up here, and then it goes into the tank. Now, this is a one-way check valve, okay? And so the air goes in the tank and cannot come back out. This right here is a bleeder line to bleed the air that's in this line coming off the bottom side of that pressure switch. So this tank has a bleeder on the bottom, and it also has a bleeder for this line right here. And now when I turn the switch on, there's not enough pressure in the tank right now because it cuts off at, I can't remember what it cuts off at, but I think it cuts off at 140. Alright, cut off. Let's see. There you go. Yeah, 140. Alright. It could go higher. Could go up to 175. But we got it at 140. That's all we need.